Okay, so I'm back, and this is now my 4.2 demonstration. And this is seeing how air moves. Okay, so I have here, I filled up my little container with ice water, obviously snow, cold surface, Arctic, Antarctic area. Okay, and I'm gonna put my convection tube over top, and that's just gonna roll out there. So just let that go, and I will demonstrate that in a second. For the other one, instead of using boiling water, I'm gonna use a candle. Like I have these little tea lights, obviously, candle, flame, heat, fire, okay? So I'm gonna put that, and I'm putting this on my tray so I don't burn my house or anything. But, so I'm going to demonstrate for you both of these ways in which we can see how air reacts. Now I'm going to use what we call as a punk stick, and some of you actually might have seen this before, like maybe incense. Maybe your parents like to light it, you blow it out, and then it produces like a smoke that smells. These I brought from school, and they're called punk sticks. Lucky for you, you get to not smell them, because I usually end up smelling like a fire pit after the end of the day. So I'm going to light this, and I want you to see how the air moves. Okay? And hopefully it works for us. So I'm going to light my candle here. And actually, I'm going to use 2 candles because I like to, more is always better. And plus, they're like dollar store candles. They don't work that well. And hopefully they don't go out on me, because that has been known to happen. All right. So this would, in essence, be what 4.1 demonstration was. But now that we're past that, now we've come to the realization that cold surface, cold air, hot surface, hot air. Now we're going to see how the air actually reacts to a cold surface or a warm surface. So I'm going to light my punk sticks. Oh. Okay. My fire detector is probably going to go off here in a second. Now you should see here, there's an automatic reaction. Do you notice something happening with my convection tubes? Does one look a little different than the other? And it's kind of an obvious observation, but one is kind of steaming up, which again is an obvious reaction when we know where heat's involved, or when we boil water, that kind of reaction. So what I'm going to do, I put it a little at the bottom. I mean at the top now. Hi. Hi. I'm working right here. I'm doing a video, so you need to back away, bud. Fortnite. Gotta love Fortnite. Okay. So you can see here that we have kind of a foggy tube here. Okay. And I'm just going to put my hands above this and see if we can then see a buildup or a reaction with our convection tubes. Can you see a reaction? I can feel a reaction. I wonder if you can tell me what the reaction is, or where I might feel temperature. Where do you think you can feel temperature? The cold side or the hot side? Okay. Now, I'll tell you that you can feel it at the hot side. You can feel the steam, the heat coming up, which is showing me that the air is coming up. Okay. Now I'm going to do this again and make this a little more obvious. I'm going to add more smoke. And you're going to, of course, if you were in my class right now, you'd be totally enjoying that part. So here we go. I'm gonna do the hot side first since my candle is still happily lit. All right, here we go.
No, do any almond. Can I have it? Where is my cube? Mom, have you seen a cube anywhere?
My crazy kid asking for a cube. Okay, so we have going on here a whole lot of heat coming onto my hands. Okay. How could we visualize this a little better? Maybe if I put, give me 1 second here. I think it'd be better if I put dark behind it. Can you see that coming out? I can see it, but I don't know if you can. I'm gonna relight this and do it again. Get a better effect here.
I need the shield.
I know, this is real life lab here going on. Real life stuff. Because we're looking to see how does the air react to a hot surface. So we obviously know that air takes up space, and there's air inside with that candle right now. So this punk stick is just masking what the air is doing. It's just trying to show us so we can see. Because otherwise, how are we going to see it?
I want it.
Can we see it? Can we see it? Oh, do you see that now? Do you see that smoke coming up? I hope you see that smoke in there coming up. I hope you see that as well as I do. Because now what I'm going to do here is go to the cold side. So we can see that the hot air is shooting up out of that convection tube. Now we're going to do the same thing with the cold side. My daughter's upstairs singing and my son's yelling at her that she's horrible. It's awesome. Now, I'm going to do the same thing with the cold, but I'm going to put this time up here. See the smoke? Now, I want us to watch the smoke. Now, if you look, it's like going up and down and swirling up and down. It's like, oh no, I don't really want to go down. I'm just going to stay up here. Because remember, we have the cold water down there, right? Cold surface. This right here is showing me that this air is like hesitant. Air likes to be hot. Things like to be hot. They would rather be hot than cold. But guys and gals, did you ever hear of like an average temperature or room temperature, this is where it comes from. These air molecules are fighting it, but they know they have a job to do. They have to go down and heat up that ice and melt that ice. Because you know, if you left a soda or a glass of water on your nightstand, Mom and Dad, Aunt Sally Sue would not be happy if that left a ring of water around the outside of it on your table. And this happens because of what is going on right now. These air molecules that you are able to see right now because they're shooting out the top are hesitating to go down to melt that ice. Now I'm going to show you something. I'm going to put this down the bottom. Let's see.
I will rocket this plane.
You will bomb the plane?
Yes.
And once you damage it, just kill yourself.
How come I won't kill you guys? No, if you need your
Now,
one, you're
I'm
gone.
going to get a closer view here.
No, can I have your shotgun?
No.
Come on. I'll leave the game right now. Someone's shooting
Now
at
you saw all that smoke that was coming out.
me.
Oh, they're hitting me.
Whoop. Where am I? There we go.
We need to get down.
It's still coming out, but it's not as heavy as it was before. Now, that tube is not getting filled.
Luke, go into the circle.
This hot air is down at the bottom, caressing and hugging this ice, working to melt the ice.
These kids are good.
Its job is melting the ice. It's swirling all around down there. And these hot molecules, because everything in this room is hotter than this ice cube, than this thing of ice. So it's down there caressing around the ice, melting the ice.
No, I can't.
So now these molecules that were hot are going down to melt the ice. They're giving off their energy to melt the ice. And this is where room temperature comes into play. If I give up my energy to you, I'm going to cool off, but you're going to warm up. And that's where we have room temperature. If I'm hot, you're cold, I give you some of my energy, and we become a happy medium. So right here, ice warms up and melts. That water temperature increases, but the air around it decreases. So they get a happy room temperature with air and water. Over here, the candle lit up the air or heated the air. So the candle or the hot surface was giving off its energy to warm up the air. Again, a happy medium. So this is a 4.2 lab demonstration that we have the air temperature changes or is dictated by the surface, because whatever is hotter, whether it be the surface or the air, it's going to give off its energy to the colder thing to warm it up. Okay? It's kind of like Miss Huber taking care of her children. I'm going to give up my energy to make sure my kids are warm, and that's going to make me colder because I'm giving up my energy. That is called heat transfer. The hotter thing gives up its energy to the colder thing to make a room a warmer temperature. Got it?